So the first part has us enter domain and range into those fields. So range has to be one of the ones on the left because those are the ones that have y. Remember, range is y. If I look at the range, its bottom is 2 and its top is 8, right? So remember, range, I'm only looking at the y values. Bottom is 2, top is 8. It doesn't go forever in either direction, so A and C are out. Again, it goes from a bottom of 2 to a top of 8. And I'm going to keep that highlighted. And then for the domain, when we're talking about x's, it goes on the left at 0. That ordered pair has 0. And then all the way on the right, it is, well, 8, 9, 10. So it goes up to 10. So 0 to 10. And again, it does not go forever in either direction, so it has to be D. So from 0 to 10. Oh, so I see the first question is really only asking for identify the domain. So we'll do domain for that one. Click on that one. And then for identify the range, I'll just need to input that again in for y. And like we had said, that goes from 2 to 8. So that's just me not listening to the question at first. So 2 up to 8. It's a check answer on that. That looks good. Part B, what is the x-intercept? There is no x-intercept because it is not crossing the x-axis. So this blue function, the graph of the function in blue, is not crossing the x-axis at all. So there is no x-intercept. What does the x-intercept say about the motion of the car? Select the correct choice below. So if the y-axis is the distance the car is from the wall, and the function never has an x-intercept, meaning it never has a point where y is 0, that means the car never touches the wall. So let's look at the answer choices. A says the car's distance from the wall is never 0, so the car never touches the wall. That sounds like what I just said. So I'm going to hit A. Answer choice B says the car touches the wall 0, however many seconds. The car never touches the wall, so B can't be right. Part C says the car's minimum distance from the wall is how many inches? Well, I guess you could figure that out, but that's not what the x-intercept is telling you because there is no x-intercept. So C is misleading, but not the answer you're going to choose. And then answer choice D says the car's distance from the wall is not 0 when it started. That's true, but it's also not answering the question, which is what does the x-intercept say about the car? So A is your answer there. What is the y-intercept? Select the correct choice. For basically any scenario, the y-intercept is going to be where the scenario begins. So in this case, the y-intercept is the beginning point, and it's where time is 0 and the distance from the wall is 8 inches. So, well, that's the context of the y-intercept. The y-intercept, quite literally, as an ordered pair, is going to be the ordered pair 0, 8. So let's click into that. Use my form for an ordered pair, and again it's 0, 8. All right. What does the y-intercept say about the car? Well, that's what I was just saying. That's where it starts. And it is 8 inches from the wall when the car starts moving. So answer choice A says the car starts at the wall. That's not true. B says the car starts at a distance of 8 inches from the wall. That's what I was saying. So B is your answer there. C, the car's minimum distance from the wall is how many inches? Well, again, that's something you can figure out from the graph. It's not the y-intercept that's telling you that. And then D, the distance from the wall is never 0, so the car never touches the wall. That is a true statement, but again, it's not what the y-intercept is telling you, so that's not true. Well, it's not the answer to this question. All right, part C. What are the maximum and minimum values of the function? What do these say about the motion of the car? Select the correct choice below, blah, blah, blah. Okay. Well, maximum and minimum values talk about the y value. So in this case, the maximum value is your starting point, right? The biggest value of y, so the furthest the car is from the wall, is 8 inches. The closest the car gets to the wall is the minimum value, which is the ordered pair 6, 2. The 2 being the y value, meaning that the closest the car got to the wall was 2 inches. So the answer choice A says the minimum is blank amount of seconds. However, maximum and minimum values are only talking about the y value, right? So I don't care about what's the minimum amount of seconds. I mean, that would be where it starts. But what I care about is the minimum value of y, which in this case is when did the car get the closest to the wall. So when I look at answer choice B, it says the minimum is blank inches. So that is 2, because the car got as close as 2 inches to the wall. It means the minimum distance of the car is, again, 2 inches from the wall, not 22. The maximum is 8 inches. There we go. And it means the maximum distance of the car from the wall is 8 inches. There we go. And that's that. Let's check our answer. So answer choice D says write a function in the form f of x equals absolute value of x minus a plus b that models the motion of the car. All right, so when I want to make a model for the car, I mean, it's even telling me that it's going to be an absolute value function. So that's good information. Also, I can tell that by looking at the graph, right? Because it's that V shape, so that's that absolute value shape. The first thing I note is that the slope of that is 1, right? Meaning, on the first half, it goes down, like for every 1 of x to the right, it goes down 1 for the y. When it gets to the vertex, and then same deal when it goes back to the right, it goes, for every 1 it goes to the right, for every 1 second it goes up a y, meaning the distance from the wall is then increasing by 1. So the slopes are 1, meaning there is no coefficient on the x. What you need to know is that the function y equals absolute value of x would just be that exact shape starting from the origin. So the only thing that's different is where the function starts from, and it's an ordered pair 6, 2. If you want to move a function to the right, you will subtract on the inside. So that's why it's going to be y equals absolute value of x minus 6. Right, because if I put minus 6 on the inside of the absolute value bars, it's going to move my absolute value function 6 to the right. If I wanted to move it to the left, then I would add 6. but in this case, I want to move to the right, so it's subtract 6. And then I also want to move it up 2. And then you're going to add 2 on the outside. Okay? And that's it. So it's really just a matter of how do I move the vertex, right? Moving it left or right is adding or subtracting something on the inside. Moving it up or down is adding or subtracting something on the outside. Okay, so the answer to this one is y equals absolute value of x minus 6 plus 2. So let's see how we type that in. All right, so, well, I'm sorry, not y, it's f of x equals. Notice how the f of x equals is already part of the field there. So I'm just typing in the right side of the equation, which would be absolute value of x minus 6. And then on the outside, so I move the cursor one to the right, it's plus 2. Okay. Let's check that. Okay. Let me know if you have any other questions.